Hello there, and welcome to the Sleep Porch. Tonight, we are stepping into a world that most people never see. A world of animals for whom life has taken rare and unexpected paths, shaped by isolation, time, and remarkable adaptation. These are creatures that exist on the edges of our awareness, hidden in remote forests, deep oceans, quiet deserts, and shrinking pockets of wilderness. If this content interests you, please take a moment to like the video and subscribe to the channel. Your support motivates us to continue creating more meaningful videos. Some were discovered only recently. Some were nearly lost before we even knew they were there. Others still move through their habitats largely unseen, carrying stories that stretch back thousands or even millions of years. Rare animals invite a different kind of wonder. They remind us how vast and surprising life on Earth truly is.
They show us how fragile survival can be, and how extraordinary it is that these beings persist at all. Each one represents a singular solution to the challenge of existence, shaped by place, climate, and chance. Listening to their stories can shift how we see the natural world and our place within it. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too. One sleepy soul at a time. For now, there is nothing you need to do. Let your shoulders soften. Let your breathing slow, and allow your thoughts to drift away as we explore this remarkable corner of the living world together. You can simply listen, rest, and wonder. Let's begin. The narwhal's tusk is a sensitive tooth with nerves that can sense the water. It looks like a spear, but it begins as a tooth that grows outward in a long spiral. Inside, it contains nerve pathways that make it more than decoration. Researchers have explored the idea that it can detect changes in the surrounding water, including temperature and salinity, turning the tusk into a kind of environmental sensor. That would be valuable in Arctic seas, where conditions shift with seasons and ice. Narwhals live in a world of dark winters, moving through leads in sea ice and diving deep for prey. They rely on sound to navigate and hunt, and they gather in groups that can thread through tight passages in frozen landscapes. The tusk also plays a role in social signaling, and it may help establish status among males. The wonder is that an animal can carry a single tooth that becomes a multi-purpose interface with its world, part signal and part sensation. The northern white rhinoceros has only 2 living females guarded around the clock. When a species reaches the point where only 2 individuals remain, conservation becomes a blend of care, biotechnology, and heartbreak. The last 2 northern white rhinoceroses are both female, which means natural reproduction is no longer possible. Scientists preserved genetic material from males that lived in the past and are now creating embryos through assisted reproduction. Because no northern white females remain to carry a pregnancy, the plan depends on southern white rhinoceroses serving as surrogates. It is a remarkable effort to stretch time using frozen cells and modern reproductive science to rebuild a population that humans helped push toward collapse. Every stage is challenging, from safely collecting eggs to making sure embryos develop properly. Even if it succeeds, the aim is not just a single birth. The goal is enough births to restore genetic diversity and create a future that can sustain itself.
For now, those two living animals are carefully watched, not as symbols, but as irreplaceable individuals. Axolotls can regrow limbs and remain in a youthful form for life. Many animals heal by closing a wound. An axolotl heals by rebuilding what was lost. After an injury, cells near the wound shift into a flexible state and organize into new bone, muscle, nerves, and skin. The result can be a working limb that integrates with the body rather than a simple patch. Even more surprising is its lifestyle choice. Instead of completing a typical salamander transformation, it usually keeps its larval features into adulthood, including feathery external gills. Scientists have learned to trigger metamorphosis with specific hormones, which reveals how development can be switched on or held back. Axolotls also carry a remarkably large genome, and decoding it has become part of the wider effort to understand regeneration. They offer a living lesson in what biology can rebuild and what it chooses to preserve. Kakapos are flightless parrots that breed only when certain trees produce an enormous, synchronized bumper crop of their seeds, nuts, or fruits. On islands where birds once lived without mammal predators, the cacao took an unusual path. It became heavy, ground-dwelling, and wonderfully patient. Its breeding is tied to a boom and bust rhythm in the forest because it needs an abundance of rich fruit to raise healthy chicks. In years when key trees produce a heavy crop all at once, the birds can invest in nesting. In lean years, they mostly wait. This means conservationists cannot simply choose a season and expect success. They must watch the forest closely, track flowering and fruiting, and be ready when the landscape signals a rare opportunity. It is a reminder that reproduction is not only about biology inside the animal. It is also about timing with the wider ecosystem down to a single tree's calendar. The ibex can survive desert life with almost no drinking water. This antelope is built for a world of sand, heat, and long distances between anything green. It can take moisture from the plants it eats, and it times its activity to reduce water loss. In the hottest hours, it may rest in shallow scrapes where the ground is slightly cooler. Its coat shifts with the seasons, staying darker in cooler months and turning paler when sunlight becomes relentless. Wide, sweeping horns help it look larger to a threat, though its best defense is often simply disappearing into open space. The tragedy is that the desert does not protect it from people. Vehicles and modern weapons can reach places that once served as natural sanctuaries. Small groups are being reintroduced in parts of North Africa, and their movements are tracked like precious signals on a map. In the ibex, you see the desert's toughness made visible, and you also see how quickly rarity can arrive. The Philippine eagle is so powerful it can hunt monkeys in dense forest. In the forests of the Philippines, there is a raptor built for strength, precision, and patience. It has broad wings for maneuvering between tall trees and a heavy beak, but can handle tough prey. Hunting in dense canopy is different from hunting over open plains. The eagle must read movement in shadows, launch from a hidden perch, and thread through branches at speed. Its eyesight and coordination turn a cluttered forest into a workable hunting ground. A breeding pair can require an enormous territory, which ties its fate to the health of whole watersheds. When old-growth forest is cut, the loss is not only trees. It is the hunting space, the nest sites, and the long-term stability a slow breeding bird needs. Conservation depends on protected habitat,
community support, and the hard work of monitoring nests in remote terrain. This eagle is a top predator, and it is also a measure of how intact a forest still is. The vaquita is the rarest marine mammal, and it lives only in one gulf.
In the northern Gulf of California, there is a porpoise so elusive that many scientists have never seen one alive. It is small, shy, and built for a life of brief surfacing and long dives. Instead of shouting across the sea, it uses high-pitched clicks that fade quickly with distance. That makes its world feel close and private. Researchers often meet it through sound first, using underwater recorders to detect those clicks in the dark water. The greatest danger is not a predator. It is a curtain of fishing nets meant for other species. When a vaquita is trapped, it cannot reach the surface to breathe. Every surviving individual matters, and conservation here feels like emergency medicine for an entire species. The solar was discovered in the 1990s, and it is still barely seen. In the mountains of Laos and Vietnam, local hunters spoke of a forest animal that seemed almost legendary. When scientists finally examined a pair of unusual long horns in the early 1990s, it was as if a new chapter opened in modern biology. The animal behind them, later called the skjola, moves through dense evergreen valleys where mist and steep slopes hide everything. It is so rarely observed that much of its behavior is still inferred from tracks, fleeting camera trap images, and the knowledge of nearby communities. Even its diet remains partly mysterious, although it appears to browse tender leaves in shaded understory. The greatest threat is not fame, but snares set for many different animals. A species can be discovered by science and still vanish almost silently. The Yovan rhinoceros survives in one park with no wild populations elsewhere. This rhinoceros once ranged across parts of Southeast Asia. Then it was pushed into a single stronghold. Today, its remaining wild home is Ujung Kulon National Park in Indonesia, where dense vegetation and muddy wallows make direct sightings rare. Conservation teams often learn its movements through camera traps, tracks, and the distinctive shape of a single horn. Living in one place brings safety, but it also concentrates risk. A disease outbreak, an invasive plant that changes food availability, or a major natural disaster could affect the entire population at once. Rangers work to reduce poaching pressure, manage habitat, and monitor individuals without disturbing them. The story is tense because it balances on one location and one small group of animals. It also carries hope because protection in that park has allowed numbers to edge upward. Survival here is not a global spread. It is a single, guarded thread. Pangolins are the only mammals with true scales, and they are heavily trafficked. A pangalim looks like it stepped out of deep time, wrapped in overlapping scales made of the same material as human fingernails. When threatened, it can fold into a tight ball that frustrates many natural predators. Humans, however, can simply pick it up. That simple imbalance has fueled one of the largest illegal wildlife trades on Earth. Pangolins are taken for meat, and their scales are sold into markets where false medical claims keep demand alive. In the wild, they are quiet workers that eat huge numbers of ants and termites, shaping ecosystems in ways people rarely notice. They also have specialized traits for that job, including powerful claws for breaking into nests and a sticky tongue for collecting insects. Rescue centers often receive malnourished individuals because an insect-based diet is hard to replace. Protecting pangolins is not only about law enforcement. It is about changing belief, reducing demand, and vetting a shy insect eater remain an essential part of its landscape. The okapi is a forest giraffe relative, hidden for centuries from Western science. For a long time, reports of a striped animal in the rainforests of Central Africa were treated like rumor. Then, evidence arrived, and the okapi became one of the most surprising large mammal discoveries of the modern era. It is related to the giraffe, yet it lives in dense forest rather than open savanna. Its velvet coat absorbs light, which helps it blend into shadowed vegetation. Those zebra-like stripes on its legs are not decoration. They can help break up its outline among shafts of light and tangled plants. The okapi also has a long prehensile tongue that can strip leaves and clean its own face with careful precision. It tends to be solitary, and it moves quietly through the understory, leaving little trace beyond tracks and dung. Protecting it means protecting the deep forest itself, because it depends on stable habitat and freedom from human conflict. The okapi is a reminder that even very large animals can stay hidden if their world is hard to enter. The pygmy three-toed sloth spends most of its life in one island mangrove. On a small island off Panama, a unique three-toed sloth lives almost entirely among mangrove trees. This population is separated from mainland relatives, which means its whole existence is defined by one narrow habitat and a limited menu of leaves. Over time, isolation can reshape a species, and island life often favors smaller bodies and specialized behavior. The result here is a sloth that is not simply rare in numbers, it is rare in geography. Its range is so small that a single storm, a disease event, or sustained disturbance could have outsized effects. Because mangroves also protect coasts and support fish nurseries, conserving this sloth overlaps with conserving an entire shoreline system. Researchers study how it uses the canopy, how it rests, and how it navigates between trees without leaving cover. When you think about rarity, this is a powerful example. A whole mammal's future can hinge on one patch of mangrove and the health of one island. The Herola antelope is so rare that most people in its range never see one. It lives in a thin strip of dry savanna near the Kenya and Somalia border, where rainfall can fail and grasses can vanish fast. In that kind of place, survival favors sharp senses and constant awareness. Herola often stand with heads high and ears turning, reading the wind for danger before it arrives. Their pale eye rings give them an alert, watchful look, which suits an animal that must spot predators early across open ground. What makes their rarity so startling is that they once shared this landscape in greater numbers, then declined within a human lifetime through disease, drought, and pressure on habitat. Conservationists have moved some individuals to safer areas, hoping to build a second refuge population. When numbers are this low, every calf matters, and every safe season feels like a small miracle. The Iberian lynx rebounded after intensive breeding and refling programs. Not long ago, this cat was so close to vanishing that each surviving pocket of habitat felt like an isolated lifeboat. Then conservation turned into a careful chain of steps. Breeding centers paired individuals to protect genetic variety, while teams prepared release sites with cover, water, and reduced road risk. When young lynx were released, they carried tracking collars that told a story in dots and lines, where they hunted, where they rested, and whether they found territory without conflict. Over time, those dots began to spread into new areas, linking landscapes that had been disconnected for decades. Rewinding is more than opening a gate. It requires cooperation from landowners, safe corridors between wild spaces, and patience for a predator that lives on its own terms. The Iberian lynx now stands as proof that a species can climb back if people commit to the long work. The Amore leopard endures harsh winters with one of the thickest catcoats. This leopard lives where snow can cover the ground for months, in forests near the borders of Russia, China, and North Korea. In winter, its fur becomes long and dense, trapping warmth close to the skin and giving the animal a larger, almost plush silhouette. Its spotted coat does more than look beautiful. The pattern breaks up its outline against patchy snow, bare branches, and shadowed rocks. Survival here demands energy discipline. The leopard may travel far on silent paws, using ridge lines and game trails to conserve effort. It is also a master of waiting, choosing a hidden vantage point and letting the forest move around it. The biggest threat is not the cold. It is the loss of prey and safe habitat, plus the risk of snares intended for other animals. Conservation in this region often looks like protecting an entire food web, because a big cat cannot persist on beauty alone. The Somatan tiger is the smallest tiger living their whole lives in rainforests. In thick jungle, size can be a disadvantage. A smaller tiger can move through tangled plants, slip along narrow ridges, and turn quickly in tight spaces. Its stripes are often dense and close together, which helps it blend into a world of vertical stems and broken light. This tiger is also a strong swimmer, which matters on an island where rivers and swamps can block a hunt or offer a shortcut. Because rainforest understory muffles sound, hunting becomes a quiet art of listening and positioning, followed by a sudden burst of speed within a few heartbeats. The deeper drama is that the same forest that protects it is also valuable to people, and land clearing can wipe out generations of hunting knowledge in a single season. Protecting this tiger means preserving large, connected stretches of rainforest, not just isolated patches. When you picture a tiger, you might imagine open grasslands. This one is a shadow among leaves, perfectly adapted to green darkness. The Sumatran orangutan is critically endangered, and it exists only on one island. High in the canopy, this great ape lives in a world of branches, fruit, and careful decisions. It is known for intelligence that appears in everyday problem-solving, from choosing strong roots through trees to using simple tools to reach food. Mothers invest deeply in their young, and a single infant may remain close for years while learning where seasonal fruit appears and how to move safely above the ground. That slow pace is part of the danger. When habitat is cut, the population cannot quickly replace what is lost. On Sumatra, forests are pressured by roads, logging, and agriculture, which can isolate groups and raise the risk of conflict. Rehabilitation centers sometimes care for orphaned individuals, teaching them forest skills before release, though success depends on having real forest left to return to. This orangutan is not just an animal in a tree. It is a long memory of the canopy, and it needs time and space to keep that memory alive.
The Topani orangutan was named in 2017, and it is already imperiled. It is rare for a great ape to be recognized as a distinct species in modern times.
Yet that is exactly what happened in the hills of northern Sumatra. Researchers combined careful field observations with genetic and anatomical evidence, and the result was a new name for an orangutan population with its own evolutionary story. The urgency is immediate, because the entire species lives in a small area of upland forest. When a species has such a limited range, even one major development project can reshape its future. Steep terrain may sound protective, but roads can slice into it, and fragmented forest can trap groups apart. Conservation here is like protecting a library that exists in a single room. You cannot move it easily, and you cannot rebuild it once it burns. The Topani orangutan reminds us that discovery is not always a celebration. Sometimes it is a warning light turning on. The red wolf survives through reintroduction after vanishing from the wild. This cyanid story is full of second chances and hard trade-offs. When the wild population collapsed, a small number of animals were brought into captivity to preserve the line. From that narrow starting point, biologists built a breeding program, then began returning wolves to parts of their former range. Once released, the challenges multiply. Roads, human conflict, and the pull of unfamiliar territory can undo years of work in weeks. There is also the constant genetic pressure of mixing with coyotes, which can blur the red wolf's identity if not carefully managed. Wildlife teams use monitoring, sterilization programs for coyotes in key areas, and active management to give the wolves room to find mates of their own kind. Reintroduction is not a single event. It is a continuing relationship between people and a predator, but is learning, adapting, and trying to reclaim a place in the landscape. The Ethiopian wolf is Africa's rarest canid, and it hunts rodents on high moors. Picture an animal shaped like a fox, moving across an Afro-alpine plateau, where the air is thin and the nights can freeze. This wolf has a narrow muzzle and a focused hunting style, because much of its diet comes from small, burrowing mammals. You may see it pause, ears forward, then pounce with a quick plunge into grass. Unlike many wolves, it often hunts alone, yet it lives in social packs that defend territories and raise pups together. That mix of independence and cooperation is part of what makes it so compelling. Its greatest dangers arrive through contact with domestic dogs. Diseases like rabies and distemper can sweep through a small population with terrifying speed. Vaccination campaigns for dogs, and sometimes for wolves themselves, have become a frontline defense. The Ethiopian wolf is a specialist living in a specialist habitat. That makes it beautiful in its precision and vulnerable in its dependence. The Darwin's fox lives in Chilean forests, and it was unknown to science for decades. In the temperate forests of southern Chile, a small fox moves through dense understory with a cautious, secretive style. For a long time, it was known mainly from limited evidence, and its true distribution was unclear. Some populations live on islands, others on the mainland, which hints at a complicated history shaped by changing landscapes and isolation. It is smaller than many people expect, with a dark coat that suits shadowed forest floors. Because it is not a wide-ranging generalist, it depends on intact habitat where it can forage without constant disturbance. Threats include habitat change, attacks by dogs, and the spread of diseases carried by domestic animals. When scientists set camera traps, a single image can feel like a message from a hidden world, confirming that the forest still holds surprises.
The Darwin's fox is a reminder that rarity is not always loud. Sometimes it is a quiet animal, moving just out of sight in a place few people enter. The fossa is Madagascar's top predator, and it evolved from mongoose-like ancestors. It looks a little like a small cougar, yet its family tree sits closer to mongoose relatives than to cats. That twist happened on an island where competition was strange and open roles waited to be filled. It can sprint on the ground, then climb into the canopy with a confidence that surprises people who expect a purely terrestrial hunter. Its ankles are built for agility, and it can descend trees headfirst when a chase demands it. Much of its hunting centers on lemurs, which means a single predator can shape the behavior of many other species across the forest. The real suspense is that it depends on large, connected habitat, and Madagascar's forests are often broken into fragments. When a top predator loses room, the whole ecosystem can wobble. The fossa is not only rare, it is an architect of balance.
The two uses a long finger to tap for grubs, then hook them out. Imagine hunting in darkness, without digging or tearing logs apart. This lemur taps along wood with quick, delicate rhythms, then listens for a hollow response that hints at hidden tunnels. Once it finds the right spot, it gnaws a neat opening with teeth that keep growing, then slides a thin finger inside like a living tool. That finger can snag larvae buried deep in the grain, reaching food that most animals cannot access. It is a style of feeding that feels almost like sonar mixed with carpentry. In some places, cultural fear has turned this rare specialist into a target, because people misread its strange appearance and nighttime habits. Conservation often includes community education, since protecting an animal can depend on how it is perceived, not only on the forest it needs. The two shows how evolution can invent a whole new way to eat. The silky sifaka can leap between trees with huge spring-loaded leg power. In western Madagascar, this lemur moves like a living catapult. It grips a trunk, coils its powerful hind legs, then launches across open air to the next tree with startling precision. Those leaps can span distances that look impossible until you see the landing, hands catching bark, body swinging into place, and balance restored in a breath. On the ground, it travels upright with a sideways hopping gait that looks almost playful, though it is simply the best use of its anatomy. The silky sifaka's real problem is that acrobatic skill cannot outrun habitat loss. When the canopy is cut, the gaps become too wide, and the safe pathways vanish. Small populations become isolated, which makes recovery harder with each generation. Watching a spark leap is thrilling, because it feels like seeing physics and life agree on something beautiful. The injury is the largest living lemur, and it sings in haunting duets. High in Madagascar's eastern forests, its calls can roll through the trees like a living chorus. A family group may sing together, voices rising and falling in patterns that seem designed to carry across distance. These songs help neighbors know who is where, and they can strengthen bonds inside the group. The injury rarely comes down to the ground, and its long legs are built for powerful vertical jumps between trunks. Unlike many lemurs, it does not keep well in captivity, which makes protecting wild habitat even more important. It also has a slow life history, with careful parenting and limited reproductive speed. That means the forest cannot be cut today and replaced tomorrow with good intentions. The Indri song is more than sound. It is a sign that an old forest still stands with enough continuity for a family to claim a home and announce it to the world. The kakapo's strong scent can reveal it to predators, which complicates recovery work. This parrot's odor is unusual for a bird. and it can be surprisingly noticeable at close range. In a world that once lacked mammal hunters, smelling distinctive may not have been a problem. Once introduced predators arrived, scent became a risk, since mammals often track by nose rather than by sight. That forces conservationists to think in ways that feel almost like spycraft. Nests must be protected, predator numbers must be controlled, and tracking must avoid drawing attention to birds that already advertise themselves. Even researchers handle work carefully, because too much disturbance can change behavior and increase danger. The kakapo's smell is also a clue to its biology, because scent plays a role in communication and mate choice. Recovery is not only about fences and sanctuaries. It is also about understanding tiny details that suddenly matter when the environment changes. The Cuban solenodon delivers venom through grooved teeth, a very rare mammal trait. Most people associate venom with snakes and spiders, not with small shuffling mammals that look like they stepped out of another age. The Cuban solenodon can inject toxic saliva through grooves in its teeth, which helps it subdue prey during a bite. It forages at night, rooting through leaf litter and soil for insects and other small animals, using a long snout and an intense sense of smell. Its movement can seem awkward, yet it survives through persistence and stealth rather than speed. This species is also vulnerable because it lives on an island with habitat pressure and introduced predators that it did not evolve alongside. When biologists search for solenodons, they often rely on signs, burrows, and patient night surveys rather than quick sightings. Venom in a mammal is rare, but the deeper wonder is that such an ancient line is still here at all, carrying a strategy almost no other mammals use. The Hispanolan solenodon is a living fossil line that predates many modern mammals. Its relatives diverged so long ago that it feels like meeting a survivor from a forgotten branch of the mammal family tree. On Hispaniola, it lives a mostly nocturnal life, slipping through understory and rocky ground while relying on smell and touch more than vision. It can use flexible snouts and strong claws to probe for prey, and it often travels with a low searching posture that seems built for a world under leaves. Because it evolved without many of the predators now present, dogs, cats, and habitat disruption can hit it hard. Conservation becomes a race against threats that arrive fast, while the animal's life history moves slowly. What makes it so compelling is not a single dramatic behavior. It is the idea of deep time made visible. The Hispanoloman solenodon carries evolutionary history in its bones, and losing it would be like tearing out pages from Earth's oldest biography. The Chinese pangolin can close its ear openings to block ants and soil. When it digs into an ant nest, the world becomes a storm of biting insects and loose debris. A simple open ear would be an invitation for trouble, so this animal can seal the openings as it works. It also has thick eyelids and strong facial muscles, but help protect sensitive areas while it breaks into nests. Its claws are built for ripping into hardened ground, and its feeding is precise with a tongue designed for quick, repeated strikes. This kind of specialization is impressive, but it comes with a cost. A specialist depends on healthy insect populations and safe forest patches, and it can struggle when landscapes are fragmented. Many individuals also face intense pressure from illegal capture, which makes every survival strategy feel tragically unfair. The ear-closing detail sounds small, yet it reveals how thoroughly the animal is adapted to its niche. evolution did not give it armor only. It gave it practical shutters and seals for a messy job. The Sunda pangalim curls into a tight ball, using scales like armor. When danger approaches, it can fold its body so completely that soft parts are tucked away, leaving an overlapping shell that is hard to pry open. The tail can wrap around like a locking strap, and strong muscles hold the posture as if the animal becomes a living vault. This defense works well against many natural threats because teeth and claws cannot easily find purchase. It also changes the way the pangolin moves through the world. It does not fight. It avoids, hides, and relies on stealth, then trusts its armor as a last resort. The tragic reality is that a defense designed for wild predators offers no protection against humans who can simply pick it up and carry it away. Rehabilitation teams often describe how stressed pangolins become, since they are solitary and highly sensitive to disturbance. Their curl is a masterpiece of survival design, and it deserves a world where it is enough. The Tibetan antelope grows an exceptionally fine underfur that once drew it into crisis. On the high plateau, winters are harsh and winds can feel like blades. To survive, this antelope develops an incredibly soft undercoat that holds warmth close to the skin. For people, that softness became a temptation. The fibers were turned into luxurious shawls, and demand fueled intense poaching that pushed the species toward disaster. What makes this story hopeful is that protection can succeed when it is enforced and sustained. Anti-poaching patrols, stronger laws, and international attention helped slow the killing, and some populations began to recover. The Tibetan antelope also performs long seasonal migrations, which means it needs broad landscapes, not only a single protected spot. Fences and development can break roots that have existed for generations. This animal represents endurance at high altitude, and it carries a lesson about how quickly beauty can become a threat, then how determined protection can give a species breathing room again. The snow leopard cannot roar because its throat bones are built differently. Instead of a roar that shakes the air, this cat speaks in a quieter language of chuffs, growls, and a sound called a yowl that can carry across cliffs. Its voice is shaped by anatomy. The structures that help lions roar are not built the same way here, so the snow leopard's power shows up elsewhere. It has an extra long tail for balance and warmth, and wide furred paws that act like snowshoes. It can launch across rocky gaps with a confidence that looks unreal, then land with almost no sound. Much of its hunting happens in steep terrain, where a misstep costs energy, and energy is life at high altitude. People often call it a ghost, not because it is mythical, but because it can live near villages and still remain unseen for years. The Maine wolf is not a true wolf, and it has its own genus. It looks like a fox on stilts, with legs built for tall grass, and the body built for a very different lifestyle than pack hunting. It often travels alone across South American savas and scrub, marking its route with a strong scent that signals ownership from far away. Its diet is a surprise. Alongside small animals, it eats a distinctive fruit called the libera, sometimes called the wolf apple, which makes it more like an omnivorous wanderer than a classic predator. Those long legs are not for speed alone. They let it see over vegetation and listen for movement, then pounce down on prey with a sharp, vertical strike. This animal's uniqueness can make it harder to protect because people assume it fits the story of other wolves. It does not. It is its own story, evolved for a landscape that rewards independence and flexibility. The doe is a social wild dog, and it communicates with many distinct whistles. In a forest where sight lines are short, a voice can be a map. Dolls use sharp whistles and chirps to keep a pack together as it moves through thick cover, and those calls can change with urgency and context. A hunt is a coordinated effort with individuals reading each other's speed and direction in real time. Unlike many canids, dolls have fewer teeth behind the canines, yet they compensate with teamwork and persistence. They also show a softer side. Packs share food with pups and with nursing mothers, and the group can function like a living safety net. Their biggest challenges are not about skill, they are about space, because fragmented habitat makes it harder to maintain packed territories, and disease from domestic dogs can spread quickly. When you imagine wild dogs, you might picture open plains. Dolls are forest strategists speaking in whistles as they move. The African wild ass is the ancestor of domestic donkeys, and it is now endangered. Long before donkeys carried water and grain for people, their wild ancestors moved through arid landscapes where survival depended on caution and endurance. The African wild ass still lives in harsh desert regions built with tough hooves and an ability to travel far between resources. It has a sharp brain call that can carry across open ground, which helps scattered groups stay in contact. Its connection to domestic donkeys is not only a curiosity, it is a reminder that a familiar barnyard animal has a rare and vulnerable wild origin. Today, the wild populations face pressure from competition with livestock, hunting, and the shrinking of safe watering places. Hybridization with domestic donkeys can also blur the genetic line that makes it unique. Protecting it is like protecting the original source code of a species that humans have depended on for thousands of years, yet now barely notice. The Pazelski's horse returned to the wild after existing only in captivity. For a time, the last truly wild horse lived behind fences, kept alive by careful breeding and by the hope that grasslands might welcome it back. The return was not simple. Horses raised in managed settings must relearn dangers, find natural forage, and form stable bands that can handle winter and drought. Conservationists chose release sites where space, water, and protection could work together, then monitored the animals as they explored and claimed home ranges. Some populations now live again on open steppe, with stallions defending groups and May teaching fows where to graze and when to move. This species is not the same as a feral horse. It carries distinct traits, including a stockier build and a different genetic history. Its comeback is one of the rare stories where extinction was reversed in practice, not just discussed in theory. A wild horse became wild again, step by step. The Saiga antelope has an oversized nose that filters dust and warms air. At first glance, it looks almost comical, as if its face was shaped by a different set of rules. That large, flexible nose is a survival tool. In summer, it helps filter dust kicked up by migrating herds across dry steppe. In winter, it helps warm, frigid air before it reaches the lungs. Saiga live in vast landscapes where weather can swing hard, and where safety often comes from numbers and movement rather than hiding places. Their migrations are ancient, and they can cover long distances in search of better grazing. The drama in their story is suddenness. Populations have crashed rapidly from poaching for horns and from disease events that can sweep through herds with little warning. When Saiga numbers drop, the steppe feels emptier, in a way that is hard to describe because fewer animals means fewer hoofbeats shaping the land. The nose is a headline feature, but it points to a deeper truth. This antelope is engineered for extremes. The pygmy hippo lives in forests, and it spends daylight hours hidden in water. Unlike its larger cousin of open rivers, this hippo prefers dense, shaded forest and quiet streams. It often rests by day in water or muddy wallows, where the coolness protects its skin and the cover hides it from trouble. At night, it becomes a careful forager, walking narrow trails through vegetation to find leaves, fruits, and fallen plants. Its behavior can feel almost secretive, and that is part of why so many people have never heard of it. Forest life demands a different kind of awareness than life in open floodplains. Sounds are closer, visibility is limited, and danger can appear suddenly. The pygmy hippo's biggest challenge is that forests can vanish in pieces, leaving animals stranded in small fragments. Protecting it often means protecting corridors along waterways, because those routes connect feeding areas and safe resting spots. This hippo is a reminder that even a large animal can live like a shadow if its world is thick with trees. The binurong smells like popcorn due to a compound in its scent glands. Most animals leave a scent that says, "This is mine." The binurong leaves a scent that makes people blink and ask, "Why does the forest smell like warm popcorn?" The aroma comes from chemicals in its scent marking, and it uses that smell to communicate along branches and trunks as it moves through the canopy. It is often called a bear cat, though it is neither bear nor cat, and it spends much of its life climbing with strong limbs and a prehensile tail that can grip like an extra hand. It eats fruit, small animals, and whatever else fits its opportunistic menu. And it plays an overlooked role as a seed spreader in tropical forests. The danger is that it is sometimes taken for the pet trade, and it also loses habitat as forests are logged. That popcorn scent may sound like trivia, but it is a doorway into a whole hidden system of animal messaging. The fishing cat can swim well, and it hunts along marshes and mangroves. Most cats avoid water. This one leans into it. With a stocky build and a focused stare, it patrols shorelines where mud, reeds, and tidal roots create a maze of hiding places for fish and frogs. It considered the edge like a patient heron, then strike with a paw that hooks prey out of the water. In other moments, it enters the shallows and swims using stealth rather than speed. Its coat pattern helps it vanish against the broken textures of wetlands, which means you can be close and never notice. The fishing cat's world is also one of the most threatened habitats on Earth. Wetlands are drained, diluted, and converted, often without much attention. When those waters disappear, the cat does not simply move inland, because its hunting style is tied to water itself. Protecting it means valuing marshes and mangroves as living systems, not as empty space waiting to be filled. The flat-headed cat is a specialist fish hunter with an unusually long skull. This is one of the least known wild cats, and it feels almost designed by engineers. Its head is long and low, and its jaws are shaped for gripping slippery prey. Its teeth and bite mechanics help it hold fish firmly, and its eyes are set for watching water edges in dim light. It lives in lowland forests and swampy areas where quiet streams and pools offer food, which also means it depends on places that humans often drain or develop first. Because it is so elusive, scientists have had to piece together its life from rare sightings, camera trap images, and scattered evidence along waterways. That uncertainty makes every confirmed record feel exciting, like a clue in a mystery that is still unfolding. The flat-headed cat is a reminder that rarity is not only about small numbers. Sometimes it is also about how little we know, even now, about an animal with a whole hunting strategy built around water. The Pallas's cat has the fluffiest fur of any cat built for cold steppe. Out on the windy grasslands of Central Asia, winter can feel endless, and hiding places can be scarce. This cat answers that challenge with insulation so thick, it changes its whole outline, making it look rounder and larger than it really is. The fur also covers its paws, which helps with warmth and with traction on icy ground. Its face is built for life in open country. Low-set ears reduce its profile when it crouches, and its flat, wide head helps it vanish behind stones and sparse plants. Instead of chasing long distances, it relies on patience and surprise. A small movement, a quick lunge, and a rodent disappears into the snow. People rarely glimpse it because it freezes so completely that even nearby hikers can miss it. The steppe has many quiet hunters. This is one of its most perfectly disguised. The marbled cat has ankles that rotate far, helping it climb down head first. Most cats climb up easily, then hesitate when it is time to come down. This little forest cat is different because its ankles can rotate much farther than most of its relatives. That gives it a special kind of confidence in the canopy. He can descend a trunk head first, gripping bark with controlled steps instead of awkward scrambling. In a rainforest, that ability matters. Food is not always on the ground, and danger can arrive from above or below. The marbled cat hunts birds and small mammals, and it uses branches like hidden roads. Its coat pattern looks like swirling clouds, which helps it blend into dappled light and tangled vines. Because it is rare and secretive, scientists often learn about it through camera traps, which catch brief moments of a striped face and a long tail moving through darkness. It reminds you that in the forest, gravity is not the only direction. Skill is. The sun-clouded leopard has very long canine teeth for its body size. In the forests of Borneo and Sumatra, there is a cat built like a climber, with a hunter's tools scaled up in a surprising way. Its canine teeth are exceptionally long compared with its body, which hints at a killing style designed for firm control of prey. This leopard is also shaped for trees. It has a long tail for balance and strong limbs that can grip branches as it moves through the canopy. Its coat carries large cloud-shaped markings that break up its outline in shifting forest light. It can rest high above the ground where fewer threats reach it and where it can watch quietly. The difficulty is that forest loss removes not only shelter, but also the elevated pathways it depends on. When trees are cut, this cat does not simply lose space. It loses the three-dimensional world that makes its lifestyle possible, and its hunting becomes harder to sustain. The Ethiopian gelada is a grass-eating primate with a complex social system. Most primates, you imagine fruit seekers in trees. Geladas are different. They live on high Ethiopian plateaus and spend much of their day sitting like careful grazers, plucking blades of grass with nimble fingers. Their world is also intensely social. Small family units stay within much larger bands that can gather in spectacular numbers, then break apart and regroup as the day changes. Males may lead units, and relationships can shift through alliances and challenges that play out with stares, postures, and local exchanges. Their calls include a rich range of sounds that help hold the group together across open ground. Sleeping often happens on cliff faces, where steep rock offers safety from many predators. Life up high is harsh, yet geladas have turned it into a community with rules and bonds that can feel almost human in their complexity. They show that intelligence is not only for hunting, it can also be for living together. The golden snub-nosed monkey thrives in snow, unusual for a leaf-eating monkey. In the mountains of central China, winters can bring deep snow and bitter cold. These monkeys meet that challenge with thick fur and an ability to find food when the forest seems asleep. They eat leaves, buds, bark, and lichens, and their digestive system is adapted to handle a diet that would not support many other primates through winter. Social life helps too. Groups huddle for warmth and coordinate movement through the trees, using calls to keep contact when visibility drops. Their striking colors stand out in photographs, yet they can still be hard to spot in a vast mountain forest. The most pressing threats come from habitat fragmentation and disturbance because a cold-adapted specialist cannot easily shift to a different kind of environment. When you picture a monkey, you might picture tropical heat. These monkeys make snow their home, which widens your sense of where primate life can flourish. The proboscis monkey has a huge nose that helps project calls across rivers. Along the rivers and mangroves of Borneo, these monkeys often travel in groups that need to stay connected across water, trees, and thick vegetation. Adult males grow an oversized nose that acts like a resonator, shaping loud calls that can travel far through humid air. The nose is also a social signal, and it is hard to miss when a male sits upright watching other groups from a riverside tree. Their lifestyle is tied to water. They are strong swimmers, and they can leap from branches into rivers when escape demands it. Their diet relies heavily on leaves and unripe fruits, which means their stomach is adapted for fermentation, and sudden changes in food can cause trouble. River edges are also where humans build, log, and convert land. So the habitats that suit them are often the first to be altered. The nose gets attention, but the deepest story is how a primate became a river specialist, shaped by sound, swimming, and shoreline forests. The slow loris has a venomous bite, mixing toxins from glands and saliva. It moves with deliberate care through branches at night, using a strong grip that let it hold on for long periods without rushing. Hidden under that calm style is a defense that surprises people. It can lick secretions from glands near its elbows, then mix them with saliva. When it bites, the combination can deliver venom, which can cause intense reactions in attackers. This is rare among mammals, and it changes how the animal handles danger. It does not need to sprint away. It can remain motionless and then defend itself if seized. Sadly, these unusual traits have not protected it from the pet trait. Some captured lorises have their teeth removed to prevent biting, which can leave them unable to feed properly and unable to survive if released. In the wild, they eat insects, tree gum, and small prey, and their slow movements help them avoid being noticed. The slow loris is a reminder that nature hides powerful chemistry inside even the most unhurried bodies. The cotton-top tamarin's wild population is threatened by habitat loss and capture. This tiny primate has a bright crest of hair that resembles a white flame above its head, and it lives in the forests of northern Colombia. Its survival depends on connected canopy, because small bodies are vulnerable on the ground, where dogs and people move easily. Family life is intense and cooperative. Adults share the work of carrying and feeding the young, making the group feel like a coordinated team rather than a loose gathering. The danger comes from two directions. Forest clearing reduces safe routes and food, and capture for the pet trade removes individuals from groups that rely on stable membership. When a breeding adult is taken, the loss is not just one animal. It is a missing role in a social system. Conservation includes habitat protection and community education, and it also includes responsible support for local livelihoods, so forests remain valuable while standing. The cotton-top tamarind shows how quickly a charming animal can become endangered when beauty becomes demand. The pygmy Mini Mamet is among the smallest monkeys, and it feeds on tree sap. It is so small that it can cling to a trunk like a living leaf. And yet it holds its own niche with fierce determination. Instead of relying mostly on fruit, it specializes in tree sap and gum. It uses sharp lower teeth to gouge tiny holes in bark, then returns later to lick the oozing reward. That means it manages a kind of personal pantry spread across a territory of favored trees. Its hands and claws are adapted for clinging vertically, and its movements are quick and precise, like a little acrobat on rough bark. Social groups communicate with high-pitched calls that can thread through dense vegetation, keeping members together while they forage. Because it is so small, it is sensitive to habitat change and to capture, and it can suffer if removed from the specific trees it depends on. The pygmy marmoset expands your idea of what a monkey can be. Not a fruit thief, but a sap farmer. The bonobo uses empathy and social bonding to reduce conflict in its groups. In the forests south of the Congo River, the Nobo communities show a social style that often surprises people who expect constant dominance battles. Tension still happens, but many disputes are softened through affiliative behavior, shared grooming, and strong bonds that can spread calm through a group. Female alliances can be especially influential, shaping group decisions about feeding and movement. Bonobos also share food in ways that can reduce competition, and they frequently use signals that communicate reassurance rather than threat. Their intelligence shows up in problem solving, but also in how they read emotions and respond to distress. It is a different pathway to survival, where cooperation can be as valuable as strength. The danger is that this species lives in a limited range, and it faces hunting and habitat pressure. When a social animal loses members, it loses relationships, learned traditions, and stability. Bonobos remind us that evolution can favor kindness, because kindness can keep a community working. The kakapo's mating system is Lee-based, with males calling for weeks. Instead of pairing off and building a nest together, males gather at chosen display sites and compete with sound. Each bird clears a shallow bowl in the ground, then begins a routine of booming calls that can travel across the night. The effort is exhausting. A male may call for hours, night after night, using the same spot like a stage. Females move through the landscape, listening, judging distance, strength, and stamina before choosing where to visit. This strategy can work when birds are common and the forest is continuous. When a species is rare, it becomes a problem of logistics as much as romance. If males are too far apart, or if females cannot reach them safely, the season can pass with no breeding at all.
Conservation teams track callers, manage access, and sometimes guide birds into better spacing so the chorus can actually be heard. The spoon-billed sandpiper has a strange beak tip that helps it sift mud. At the end of its bill, the tip flares into a small spoon shape, and that design changes how it feeds. On tidal flats, it sweeps side to side through shallow water and soft mud, feeling for tiny prey that most birds would miss. It is a method that looks almost like mowing a lawn, steady and precise, with each sweep sampling a new strip of sediment. The bird's life is shaped by distance, too. It depends on coastal stopovers, where it can refuel during long migrations. And those stopovers must be productive, safe, and timed to the seasons. When key mudflats are developed or disturbed, the problem is not only less food, it is fewer reliable stepping stones along an entire route. Conservationists work across multiple countries because a bird that crosses oceans cannot be saved in only one place. This sandpiper is small, but its journey is vast, and its spoon tip is a signature of that specialized life. The California condor came back from the brink after captive breeding saved it. At its lowest point, the species depended on a bold decision: bring every remaining individual into human care, then rebuild from there. That meant learning how to breed a bird that matures slowly, bonds strongly, and needs space. Keepers used careful pairing, monitored nests, and sometimes used puppet feeding, so young birds would not imprint on people. Over time, chicks became juveniles, then adults, and the next step began, returning them to open landscapes where they could soar again. Release is not the finish line. Condors face hazards like lead fragments in carrying collisions and exposure to toxins. Many birds carry transmitters, so teams can respond quickly if one stops moving or begins to range into risky areas. The result is one of conservation's most dramatic reversals. Not because it is simple, but because it demanded decades of persistence. A giant scavenger nearly vanished, then reclaimed the sky through sustained human commitment. The kakapo's eggs are vulnerable to cold snaps, so nests get careful monitoring. A nest on the forest floor may sound safe, but temperature can turn it into a fragile gamble. If conditions suddenly cool, eggs can lose heat faster than a parent can replace it, especially during brief absences to feed. Conservation teams watch nests closely, using sensors and cameras to learn what is happening without constant disturbance. When weather shifts, they may respond with targeted support that keeps the clutch within a safer temperature range. Sometimes the best intervention is subtle, reducing stress and letting the parent continue naturally. Sometimes it is more hands-on, timed with extreme conditions. This work is intense because every egg carries outsized importance, and failure can ripple through an entire season. It also reveals how narrow the margin can be for a species that evolved under very different pressures. A single cold spell can matter, and the difference between loss and success can be measured in hours. Monitoring turns uncertainty into information, and information into survival. The forest owlet was rediscovered in India after being feared extinct for decades. For years, it lingered in the category that haunts conservation. Not confirmed alive, not officially gone either. Then, reports began to sharpen, and the bird was found again in central India. Proof that small populations can persist in quiet corners. Rediscovery is thrilling, yet it arrives with a hard truth. If a species can disappear from view for decades, it can also disappear for good without anyone noticing in time. The forest allowed
depends on specific woodland structure, with old trees for nesting and open patches for hunting. When those conditions are replaced by uniform plantations or heavy disturbance, the habitat can look green but function poorly. Protecting the bird means protecting a particular kind of forest, not just any tree cover. It also means patient surveying, because rarity makes detection difficult. The owlets return to the record as a second chance, and second chances are always urgent. The night parrot of Australia is so elusive that confirmed sightings are extremely rare. This bird became a kind of national mystery, a parrot that seemed to exist more in rumor than in daylight. It lives in remote, arid habitats, and it is active at times when people are least likely to see it. When evidence appears, it is often indirect. A call heard at night, a feather found, a brief camera trap image, or a sudden flush from spin effects. Each clue is treated carefully because mistakes can mislead effort and invite unwanted attention. The greatest danger is that publicity can bring disturbance, and disturbance can be fatal for a bird that depends on secrecy. Researchers keep locations closely guarded and rely on sound recorders, discreet fieldwork, and slow accumulation of proof. Its story is captivating because it reminds us that modern landscapes can still hold hidden lives. Even with satellites and drones, some animals remain masters of not being found. The night parrot is not just rare, it is an expert in absence, and that makes every confirmation feel like a small miracle. The Madagascar pochard is one of the rarest ducks surviving on a few lakes. For a long time, it was thought lost. Then, a small surviving group was found in a remote wetland, clinging to a place that still met its needs. A duck's world is not only water. It is also the plants and insects that water supports, the nesting cover along the shore, and the seasonal stability that lets birds raise young. When wetlands are drained, overfished, polluted, or choked by invasive vegetation, a lake can remain on the map while becoming useless as habitat. Conservation here has involved protecting remaining sites and establishing safer populations through managed breeding and carefully planned releases. The challenge is that each lake is its own system, with its own threats, so solutions cannot be copied and pasted. Every breeding season becomes a test of whether the habitat is truly recovering. The Madagascar potted shows how a species can be reduced to a handful of places, and how those places must be defended like treasures. The barley mina is brilliant white, and it has been targeted by illegal trade. Its snowy plumage and blue skin around the eyes make it unforgettable, which is exactly why it has been taken from the wild. Demand for cage birds can be ruthless, because it removes individuals faster than a small population can replace them. On barley, protecting this meaner has meant more than putting up signs. It has required breeding programs, guarded release sites, and local partnerships that make living birds more valuable in nature than in captivity. Reintroduction is delicate. Birds must learn where to feed, where to roost, and how to avoid danger. And those skills are not automatic for individuals raised with human care. There is also the human side, enforcement against poaching, and the long work of shifting social norms. The mina's whiteness is not just beauty, it is a spotlight. And a spotlight can be risky in a world where rarity becomes currency. Its recovery depends on patience, vigilance, and community pride. The helmeted hornbill is hunted for its solid casque, which is carved like ivory.
On its bill sits a thick structure called the casque, and in this species, it is unusually solid.
That density made it a target because it can be carved and polished, and it has been traded in ways that mimic the market for ivory. The tragedy is that hornbills are not quick breeders. Pairs bond, and the nesting process is extraordinary. The female seals herself inside a tree cavity with a wall of mud and fruit pulp, leaving only a narrow slit. The male must deliver food through that opening for weeks, supporting his mate and the growing chick without fail. When adults are killed, a nesting attempt can collapse and the loss ripples forward. Hornbills also play an important ecological role as seed dispersers, carrying fruit far across forests. When they disappear, the forest can change from the inside out. Protecting the helmeted hornbill means reducing hunting pressure and keeping large forest blocks intact so these slow, devoted breeders can persist. The kiwi lays an enormous egg compared with its body size.
A kiwi may look round and modest,
Yet it produces an egg that seems almost impossible for it to carry. The investment is intense. Building that egg requires time and energy, and it can change the bird's movement and appetite in the lead up to laying. Once the egg is laid, the next chapter begins. Depending on the species, the male often takes on a major share of incubation, staying close to the nest and keeping the egg warm through long, patient shifts. The chick that hatches is unusually well developed, which can help in a life where independence matters early. Kiwi live by scent and touch as much as sight, probing soil with a bill that has nostrils near the tip. They also face predators introduced by humans, which makes nests and chicks particularly vulnerable. The giant egg is not a gimmick. It is a strategy, a gamble that pays off only if the nest stays safe long enough. The shoebill can stand motionless for long periods, then strike with sudden speed. In swampy wetlands, patience can be more powerful than chasing. This bird holds a statue-still posture among papyrus and reads, watching for ripples that betray a lungfish or a frog. The stillness is not laziness. It is a hunting tactic that saves energy and avoids warning prey. When the moment arrives, the head snaps forward and the huge bill clamps down with a decisive, heavy motion. That bill is shaped like a scoop and the clamp at the same time, built to grab slippery animals and hold them firmly. After the strike, it may shake prey to subdue it, then swallow with an unhurried confidence. Shoebills also nest in remote marshes where access is difficult, which helps explain why they feel so mythical to many people. Watching one hunt is like seeing time change gears from silence to lightning. The Kirtland's warbler depends on young jack pine ants created by fire and management. This songbird's life is tied to a very specific stage of a forest, not too old and not too open. It nests on the ground beneath young jack pines where branches create cover from above and shade keeps the microclimate stable. Historically, wildfire created these patches in a shifting mosaic. As firs were suppressed, the habitat shrank and the birds' numbers fell with it. Conservationists responded with an unusual solution. They helped the forest behave the way it used to. Land managers plant jack pines in patterns that mimic natural regrowth, and they use controlled burns, where appropriate, to renew the cycle. The outcome is a reminder that protecting a species sometimes means protecting a process, not just a place. When the pines reach the wrong age, the bird has to move on, because the ideal home is temporary by design. The takahe is a large, flightless rail
that was once believed to be extinct in New Zealand. For decades, it existed like a ghost, preserved only in museum drawers and old stories. Then it was rediscovered in the wild, alive in remote mountain regions.
That moment felt as if the land itself had been keeping a secret. The takahe is striking, with bold colors and a sturdy body built for walking through harsh alpine vegetation rather than flying. It feeds by cropping grasses and tussocks, using strong legs to move through terrain that would wear out many birds. Because it cannot fly, it is especially vulnerable to introduced predators. Recovery has therefore required intense protection, predator control, and carefully managed populations on safer islands. Every breeding pair becomes valuable, and every chick is followed like a small victory. The takahe story is not only about survival. It is about how quickly a species can vanish from view and how surprising it is when it returns. The whooping crane's recovery relies on careful migration training and wetland protection. A crane's life is a map written in instinct, and that map depends on safe places to rest and feed along the way.
When numbers became dangerously low, conservationists had to rebuild not only a population, but also a route. Some young cranes were guided on their first migrations using aircraft, which helped teach them where to go without teaching them to follow people as parents. It is a strange image, a wild bird learning a skyrow from a human-made tool. Yet it reflects how complex recovery can be. Alongside that training, wetlands must be protected and restored because a migration corridor without reliable water is like a highway without fuel. The cranes need shallow marshes for roosting and open areas for foraging, and they need those sites year after year. Their comeback shows how conservation often becomes choreography, aligning behavior, habitat, and safety across thousands of kilometers. The Philippine crocodile is critically endangered, and it lives in freshwater habitats. Unlike the big crocodiles of salty coasts, this species belongs to rivers, lakes, and marshy waterways.
It is a top predator in its freshwater world, helping regulate fish and other prey. And that role can keep ecosystems from tipping out of balance. Yet it faces a hard problem. It shares the same waters people depend on for farming, fishing, and daily life. When wetlands are drained or polluted, the crocodile loses nesting sites and safe refuge, and conflict can rise when fear replaces familiarity. Conservation programs often focus on community-based protection, where local people help guard nests and report sightings, turning a feared animal into a shared responsibility. Captive breeding and release can support recovery, but only if the habitat is still healthy enough to receive it. The Philippine crocodile's rarity is not because it is weak, it is because its home has become one of the busiest places on an island. The gharial has a long, narrow snout built for catching fish efficiently. In wide rivers, speed and precision matter more than brute force. The gharial's snout is slender and lined with sharp teeth that interlock like a cage, ideal for gripping fish as they twist and flash. Its body is also shaped for water, with a powerful tail that drives it forward in quick bursts. On land, it looks awkward and vulnerable, which is why it spends much of its time in the river itself, basking on sandbanks only when conditions feel safe. The greatest threats come from changes to rivers, including dams, sand mining, and fishing practices that can tangle or starve aquatic predators. When river flow is altered, nesting beaches can erode or flood, and eggs can be lost without warming. Protecting gharials often means protecting a river's natural rhythms, because this animal is not merely living near water, it is built from the river outward. The totara is not a lizard, and it represents an ancient reptile lineage. At a glance, it can fool you into thinking it is just another reptile in the sun, but its heritage is far older and far more unusual. The tuatara belongs to a lineage that split from other reptiles long ago, and it has kept traits that feel almost like a time capsule. It grows slowly, lives a long time, and often survives best in cool coastal climates rather than tropical heat. It can be active at temperatures that would slow many lizards, and it uses burrows for shelter and stability. On some islands, it has shared burrows with seabirds, creating a surprisingly intertwined community beneath the ground. Because it is vulnerable to introduced predators, many populations persist in protected areas, often on islands where biosecurity is strict. The tuatara's value is not only rarity, it is perspective. It shows that the present day still contains living branches from deep evolutionary history. The plowshare tortoise is one of the most trafficked reptiles despite strict protection. Its shell has a distinctive shape, and that beauty has made it dangerously desirable. Illegal collectors targeted for private collections, and even a few removals can devastate a population when the species is already limited in range. The plowshare tortoise lives in dry forests and scrub in Madagascar, where it depends on intact habitat and a slow, steady life rhythm. Like many tortoises, it matures slowly, which means it cannot quickly replace adults that are taken. Conservation efforts include patrols, secure breeding programs, and high security measures that feel more like protecting jewels than protecting wildlife. Yet the real goal is not to keep animals behind barriers. It is to keep them in the wild, doing the quiet work of grazing and shaping vegetation over decades. This tortoise highlights a painful truth that rarity can create its own threat. When something becomes scarce, some people want it more, and protection must become smarter than demand. The radiated tortoise has a striking shell pattern, and it is threatened by harvesting. Its shell is marked with bright lines that spread outward like sun rays, and that pattern can make it instantly recognizable, even to someone who knows little about reptiles. In the dry landscapes of southern Madagascar, it moves slowly through thorny vegetation, feeding on grasses, leaves, and fallen fruits. Its pace is part of its strategy, conserving water and energy in a harsh climate. The danger comes when people collect it for meat or for illegal trade, because slow breeding means losses stack up faster than recovery can keep up. It also faces habitat change, since fires and land conversion can erase the plant communities it relies on. Conservation groups work with local communities, since long-term protection depends on practical alternatives and shared stewardship. The radiated tortoise is more than a beautiful shell. It is a long-lived gardener of arid ecosystems, and losing it would change the landscape in quiet, lasting ways. The Mary River turtle breathes through Cloal Bursey, letting it stay underwater longer. In Australia's freshwater rivers, this turtle has an ability that sounds almost unbelievable. It can take in oxygen through specialized structures inside its claw. That does not replace lungs, but it can extend time underwater, which helps the turtle rest, hide, and conserve energy in flowing water. It is also known for an unusual look in some juveniles, with algae growing on the head like green hair when conditions allow. The species depends on clean, well-oxygenated rivers with stable nesting banks, and that dependence creates vulnerability. Dams can change water flow and temperature, and altered flow can affect nesting success and hatchling survival. Predation on eggs can also be intense, where foxes and other introduced animals are present. Conservation involves protecting nesting sites, managing river health, and sometimes relocating eggs to safer incubation. This turtle feels like a reminder that evolution can be wonderfully inventive, finding new ways to breathe in a world where breathing should be simple. The Chinese giant salamander is among the largest amphibians, and it is critically endangered. In cold, fast rivers, this animal lives like a shadow under stone. It can grow to a size that feels unreal for an amphibian, with a broad head, loose, wrinkled skin, and a wide mouth built for sudden suction strikes. Instead of chasing, it waits in crevices where currents deliver scent and vibration clues. At night, it becomes more active, sliding along the riverbed to ambush fish, crustaceans, and anything it can pull in. It breathes partly through its skin, which means clean, oxygen-rich water is not a preference. It is a requirement. Its decline has been driven by habitat change and heavy harvesting, and many remaining wild populations are fragmented. Conservation now includes protected river reaches and carefully managed breeding. Yet, releasing animals is complicated by disease risk and genetic mixing. This salamander is a reminder that a river can hold giants, and that giants can still disappear quietly. The M lives in caves, and it can survive years with very little food. Deep underground, where some might never reaches, the M spends its life in a slow, steady mode that feels almost dreamlike. Its skin is pale, its eyes are reduced, and its senses shift toward touch, smell, and subtle water movement. Food in caves arrives unpredictably, often washed in during floods. So the M is built for patience. Its metabolism can run so low that long fasting is possible without panic. In that darkness, small choices matter.
A sheltered crevice can mean safety from currents, and a slight change in water chemistry can signal danger.
The M also lives a long time, and it grows slowly, which matches a world where nothing happens quickly. Human threats arrive from above ground, through groundwater pollution and altered water flow that can change entire cave systems. When you picture rare animals, you might imagine distant jungles. This one lives beneath your feet in silent water, surviving on almost nothing. The purple frog emerges briefly to breed after living underground most of the year. Most of its life is spent below the forest floor in India's western Ghats, burrowing through soil where the air is damp and cool. Its body is shaped for that hidden work with a rounded form, short limbs, and a pointed snout that acts like a shovel. Then the monsoon arrives and the rhythm changes. For a short window, adults surface to breed, often in and around temporary water channels that appear with heavy rain. Males call from concealed spots, and their voices can sound muffled, as if the earth is speaking back. After mating, the frogs retreat underground again, leaving eggs and tadpoles to develop in flowing water. This compressed breeding season makes the species vulnerable to habitat disruption because there is little time to recover from disturbance. The purple frog shows how an animal can be both real and almost unseen, living like a secret that reveals itself only when rain unlocks the landscape. The golden mantle frog is tiny and toxic, and it is native to Madagascar. It is small enough to sit on a coin, yet bright enough to catch the eye instantly, glowing in yellows and oranges that signal danger. The toxins it carries help deter predators, and those toxins are linked to its diet in the wild, which often includes certain small insects. That means captivity is not a simple copy of nature, because the chemical story depends on what the frog eats and where it lives.
In Madagascar's forests, it shelters in leaf litter and near shallow pools where breeding takes place when conditions are right. Its survival is tied to microhabitats, damp ground, intact canopy, and clean water that does not dry too quickly. When forests are cleared or degraded, those fine-scale conditions unravel. The tragedy is that a frog this striking can also be collected for trade, which adds pressure to populations already squeezed by habitat loss. The golden mantle reminds you that rarity is not always large and dramatic. Sometimes it is jewel-sized and just as fragile. The Titicaca water frog has loose skin folds that help it absorb oxygen. High in the Andes, Lake Titicaca holds cold water with less available oxygen than land lakes. This frog meets that challenge with a body that looks almost oversized for its skeleton. Loose folds of skin increase surface area, which helps gas exchange through the skin while it stays underwater. It can spend much of its time on the lake bottom, moving slowly among aquatic plants and rocks. In such a cold environment, energy is precious, so a sit-and-wait lifestyle makes sense. The threats it faces are painfully modern. Pollution, introduced fish, and harvesting have all pressured populations, and disease can add another layer of risk. Conservation includes habitat cleanup efforts and protected breeding, yet recovery depends on the health of the entire lake system. This frog is not only an oddity of anatomy, it is a living response to thin air and cold water, shaped by elevation in a way that feels almost extraterrestrial. The Chinese sturgeon migrates in rivers, and dams have disrupted its ancient route. Some fish are born in the sea and return to rivers. Others do the opposite. This sturgeon belongs to an old lineage that has relied on long river journeys to reach spawning grounds, with timing tuned to seasonal flow and temperature. For a large fish, a river is not just water. It is a corridor of cues, current speed, sediment, and chemistry that guides movement. When dams rise across that corridor, the river's map can break. Migration may be blocked outright, or the signals that trigger spawning may change, leaving adults ready to breed in the wrong place at the wrong time. The species has also faced pressure from overfishing and habitat degradation, which compounds the problem. Conservation responses include fishing limits, hatchery support, and efforts to understand how flow management might help restore conditions that spawning requires. The Chinese sturgeon carries deep time in its armored body, and it shows how a single barrier can interrupt a story written across thousands of seasons. The coelacanth was thought extinct until it was found alive in the 20th century. For decades, it belonged to the category of lost worlds, known from fossils and assumed gone. Then living individuals were discovered, and biology had to make room again for an animal that seemed to have stepped out of deep history. Coelacanths live in the ocean's dim zones, often near steep underwater terrain where caves and ledges provide shelter. Their lobed fins move with a slow, deliberate rhythm that looks almost like walking in water. And that motion hints at ancient evolutionary experiments in how vertebrates could move. They are not common, and they are not easy to study because their habitat is hard to reach, and their lives unfold quietly in darkness. Their survival is threatened by accidental capture and by slow reproduction, which makes losses hard to replace. The wonder of the coelacanth is not only that it exists, it is that the modern ocean can still hide something we once believed was gone forever. The red handfish walks on fins, and it lives in limited coastal waters. This fish does not glide through open water like most people imagine. It uses its pectoral fins like little limbs, stepping along the seafloor with a careful, almost awkward gait. That walking style suits a bottom-dwelling life where the goal is not speed but precision, staying close to shelter and searching for small prey among rocks and algae. Its world is also narrow. It lives in specific coastal habitats where water quality, seabed structure, and suitable spawning surfaces all matter. When those conditions are disturbed by pollution, sediment, invasive species, or coastal development, the fish cannot simply relocate to any nearby bay. Reproduction adds another constraint. Since eggs are laid on particular substrates and need stable conditions to survive, conservation often focuses on protecting small areas intensely, because the species can be restricted to surprisingly small patches of sea. The red handfish is a reminder that rarity can happen underwater without anyone noticing, and that even a fish can have a footprint, not a fin stroke. The sawfish uses its toothed rostrum to sense prey with electricity detection. That long, saw-like snout is not just a weapon, it is a sensory device. Embedded along it are receptors that can detect the faint electrical signals produced by living animals, which means a sawfish can locate prey even when water is murky and visibility is poor. Once it finds a target, the rostrum can swing in a fast arc, stunning fish and pinning movement long enough for a capture. This tool also comes with a terrible vulnerability. The same shape that helps it hunt makes it easy to tangle in nets and lines, and escape can be difficult. Many sawfish populations have fallen sharply because of fishing pressure and habitat destruction, especially in shallow coastal and estuarine nursery zones where young fish develop. Protecting them requires safer fishing methods, strong legal enforcement, and the preservation of warm, productive, shallow waters. The sawfish stands as a living illustration of evolution. It represents nature building a multi-purpose tool part antenna, part blade only, for humans to turn that same instrument into a liability. The devil's hole pupfish survives in a single small desert cavern pool. In the Mojave Desert, a limestone cave holds one open pool that seems far too small to support an entire species. And yet, it does. The pupfish that lives there is adapted to extremes: warm water, limited food, and a habitat that can change with tiny shifts in water level. Its entire population can be counted, which makes every change feel personal and urgent. When water levels drop, the shallow shelf where algae grows can shrink, and that shelf is essential for feeding and spawning. Because the site is so specialized, conservation becomes highly hands-on, with careful monitoring, habitat protection, and even backup populations maintained in controlled settings in case disaster strikes. The species also carries a strange kind of fame, since it has been at the center of legal battles over water rights and desert groundwater use. The devil's hole pupfish is a lesson in scale. A whole evolutionary lineage can be balanced on a pool smaller than many living rooms, and that is both astonishing and unsettling. The wami pine is a living tree fossil found in an Australian canyon. In the late 20th century, hikers in a remote sandstone gorge stumbled on a grove of trees that seemed to belong to another age. Botanists later realized they were looking at wami pines, a lineage known from fossils but not expected to be alive today. The trees have dark, knobby bark,
that looks like bubbling chocolate, and their leaves grow in tidy ranks that give branches a soft, fern-like texture. What makes the discovery feel so dramatic is how small and sheltered the wild population is. A single canyon hidden by cliffs and distance acted like a natural vault for survival. That same secrecy is now part of the protection plan, because too much attention could bring disease, trampling, or fire risk. The whammy pine reminds you that extinction is not always a clean ending. Sometimes life lingers quietly in a place few people ever enter. The Komodo dragon can reproduce without mating, in rare cases, through parthenogenesis. On islands where meeting a partner is not guaranteed, nature sometimes keeps an emergency door unlocked. Female Komodo dragons have, in rare situations, produced offspring without mating, through a process called parthenogenesis. It is not the usual path, and it is not a replacement for healthy breeding populations, but it is a startling example of biological flexibility. This capability can help a lone female start a new population if she reaches a new highland, though the genetic consequences are complicated and can limit long-term resilience. The dragon itself is already extraordinary. It is a large predator that patrols dry savanna and forest edges, using sharp senses and steady patience to find food. Parthenogenesis adds another layer to the story because it shows that survival is not only about strength and teeth. Sometimes, survival is also about reproduction finding a way, even when the usual rules are missing. The kakapo recovery uses genetic management to protect diversity in a tiny population. When a population becomes very small, it faces a quiet danger that is not visible in the forest. Genetic diversity can shrink, and that can raise the risk of inherited problems over time. Conservation teams address this by treating every breeding decision like a long-term investment. They use detailed pedigrees and modern DNA tools to choose pairings that preserve rare lineages and reduce close-related mings. It is careful work, because the goal is not simply more chicks in one season. The goal is a future population that can stay healthy across many generations. This management also guides where individuals are moved, which birds are prioritized for breeding opportunities, and how new chicks are tracked from their first days. It can feel almost like running a living library, where every book matters, and duplication is not always helpful. The cacao's recovery shows how conservation can become both fieldwork and genetics working hand in hand. The northern bald ibis is being reintroduced after vanishing from much of Europe. For centuries, this bird's unusual silhouette, bare head, and curved bill were part of European landscapes and folklore. Then, it disappeared from much of that range, leaving only scattered memories and distant populations elsewhere. Reintroduction efforts aimed to restore it to places it once used. But the work is far more than releasing birds and hoping. Young ibises must learn safe routes, suitable feeding areas, and the timing of seasonal movement. Some projects guide initial migration so the birds can establish a reliable pattern, then continue it on their own in later years. That makes every early season feel like a high-stakes lesson in geography. Success also depends on protecting nesting sites from disturbance and ensuring that feeding grounds remain productive. The northern bald ibis is a reminder that a species can vanish from a continent, not because it was weak, but because conditions shifted against it. Reintroduction is an attempt to turn history around, one flight at a time. The kakapo's chicks can be fostered, which boosts survival during tough seasons.
In a difficult year, a parent may not have enough food to raise every chick successfully. Conservationists sometimes respond with a strategy that sounds simple, yet requires deep knowledge of behavior. They move a chick to another nest, where a parent is better able to feed it, and where the timing is close enough that the foster care can work naturally.
The goal is not to replace parenting with humans. The goal is to let birds do what they already know how to do, with a little help in the right moment. This kind of fostering demands careful matching of chick age, nest conditions, and the foster parent's capacity, because a mismatch can cause stress or rejection. When it succeeds, it increases the number of young that reach independence without changing the chick's essential bird upbringing. It is a vivid example of conservation as problem solving, using social behavior as a tool. In a small population, saving one extra chick can shift the entire season. The glass frog has translucent skin, letting you see organs through its belly. In the rainforests of Central and South America, some frogs sit on leaves above streams, and their bodies seem to borrow the leek's own light. When you look from beneath, the skin can be translucent enough that you can glimpse a beating heart and looping intestines. This is not a party trick. It is a form of camouflage, because a frog that blends into bright green foliage is harder for predators to spot. Many glass frogs lay eggs on leaves that hang over water, so when tadpoles hatch, they drop into the stream below, beginning life in a different world. That life cycle ties them to clean, flowing water and intact forest canopy. When forests are cleared, sunlight heats streams, sediment clouds the water, and breeding sites vanish. The transparency that fascinates people also points to fragility, because these frogs depend on precise conditions. The glass frog feels like proof that nature can make an animal look like a window and still keep it alive in the wild. The star-nosed mole can identify prey by touch in a fraction of a second. If you could see the world through your fingertips, you might hunt like this mole. Around its nose is a ring of fleshy tentacles, forming a star-shaped sensory organ packed with touch receptors. In dark, muddy tunnels, that star becomes its eyes, sweeping over the ground and reading texture at remarkable speed. The mole can detect and decide on prey in an instant, then snap it up before the opportunity is gone. It is not only fast, it is efficient, because each movement gathers information and drives action. Wetlands and soft soils suit it best, which means its fate is linked to habitats people often drain or develop. When you imagine a mole, you might imagine slow digging and silence. The star-nosed mole is more like a high-speed scanner, turning touch into a hunting superpower. It is one of the clearest examples of evolution building a sense, then building a lifestyle around it. The naked mole rat resists cancer unusually well, and it thrives in low-oxygen burrows. Underground colonies can feel like a different planet, hot, crowded, and low in oxygen. Naked mole rats flourish there, living in cooperative groups with tunnels that can stretch across large areas. Their bodies are adapted for that environment, with low energy demands and a tolerance for conditions that would stress many mammals. What has drawn intense scientific attention is their unusual resistance to cancer compared with typical rodents, which suggests their cells handle growth control and damage in distinctive ways. Researchers study them for clues about aging, repair, and how tissues stay stable over time. Their social structure adds to the intrigue because colonies have a breeding cream and many workers, which resembles insect societies more than most mammals. In the wild, their survival depends on hard soils, reliable plant tubers, and stable underground conditions. The naked mole rat shows that rarity is not the only kind of strange worth noticing. Even the common-looking burrower can carry biological surprises that challenge what we assume about mammals. The echidna lays eggs, making it one of the few egg-laying mammals. This animal looks like a small bundle of spines with a curious snout, yet its reproduction belongs to an ancient mammal story. Echidnas lay a single leathery egg, then keep it safe in a temporary pouch until it hatches. The newborn, called a puggle, is tiny and helpless, and it continues developing while the mother nurses it in a sheltered burrow. This combination of egg-laying and milk-feeding is rare, and it links echidnas to the earliest branches of mammal evolution. The rest of its life is just as specialized. It uses strong claws for digging and a long, sticky tongue for gathering ants and termites, and it can sense prey through subtle cues in soil. Echidnas can also lower their body temperature and slow down when conditions are harsh, which helps them survive in challenging seasons. They are living reminders that mammals did not begin with one blueprint. Some kept the egg and built everything else around it. The platypus senses prey with electroreceptors, and it has venomous spurs in males. When a platypus dives with eyes and ears closed, it does not hunt by sight or sound. It hunts by electricity. In its bill are electroreceptors that detect faint signals from muscle contractions in small aquatic animals, allowing it to locate prey in cloudy water and along the riverbed. It sweeps its head side to side, building a map from those signals, then snaps up insects and crustaceans. This sensory world is so different from ours that it feels almost like a sixth sense. Male platypuses add another surprise. They have spurs on their hind legs connected to venom glands used in conflicts with other males, especially during breeding season. The venom can cause intense pain in humans, though it is not considered lethal. The platypus brings together traits that seem borrowed from several animals, yet it is entirely its own. It is a reminder that evolution is not always tidy. Sometimes it makes a masterpiece by mixing tools. The leafy sea dragon relies on camouflage, and it cannot grasp with a curled tail. If you watch it in the water, it barely seems to swim at all. It drifts, it tilts, it pauses, and the ocean plants appear to drift with it. Those leaf-like fronds are not for grabbing or pushing water. They are for disappearing. The fish moves with small fins that flutter so subtly they can be hard to notice, which helps it stay quiet in the current. Unlike many of its relatives, it cannot wrap its tail around seaweed to anchor itself. That means it must choose its shelter carefully, and it depends on healthy kelp and seagrass beds that provide both cover and food. When storms, warming water, or coastal disturbance reduce those habitats, camouflage has less to blend into. The leafy sea dragon feels like a living illusion, and it survives by making predators doubt what they are seeing. The Philippine tasia has huge eyes, and it can rotate its head far around. In the dim hours of the night, this small primate hunts with a face built for darkness. Its eyes are so large that they gather every available scrap of light, yet they do not swivel like ours. Instead, the neck does the work. The head can turn so widely that it seems to look behind itself without moving its body. That matters when you are perched on the branch, listening for insects and small prey, while also watching for danger. A tasia can sit very still, then launch in a sudden leap,
landing with a grip that looks effortless. Its fingers and toes are made for clinging, and its jumps can carry it between vertical supports like a living spring. The threat is that a hunter this specialized needs intact forest structure. When trees are thinned or broken into small patches, the distances between safe launch points become risky. The kakapo cannot fly, so cats and stows are a serious threat.
The bird that walks instead of flies has to solve danger in a completely different way. This parrot can climb well, and it can freeze in place, trusting stillness to hide it. That strategy worked in a world without ground-hunting mammals. Once cats and stows entered the picture, stillness stopped being enough. A predator that follows scent and movement along the forest floor can find a nesting bird or a wandering adult, and the bird cannot escape into the sky. That is why modern recovery has leaned on predator-free islands and fenced sanctuaries, places where the rules are closer to what the bird evolved for. Rangers work to keep those places secure because one breach can have serious consequences. The story here is not about weakness. It is about mismatch. A flightless parrot meets a new kind of hunter, and survival depends on rebuilding a safe world around it. The giant pangolin has a tongue longer than its head, stored deep in the chest. It feeds on ants and termites in a way that feels almost mechanical, as if it carries a specialized tool that can extend and retract on command. The tongue is that tool. It is extraordinarily long and anchored deep within the body rather than just in the mouth. When a pangolin feeds, the tongue shoots out with speed and accuracy, coated in sticky saliva that gathers insects by the dozens. It then pulls back and repeats the motion again and again until a nest is cleared. The animal's skull is shaped around this lifestyle because it doesn't need large chewing teeth for soft prey. Instead, it needs reach, grip, and persistence. At night, it moves with quiet strength, ripping into hardened termite mounds with heavy claws that resemble chisels. This feeding system is so specialized that protecting the species means protecting its insect-rich habitat as well as the animal itself. The giant pangolin is a reminder that evolution can craft a single, perfect trick, then build an entire life around it. The mountain gorilla population has grown, but it still relies on constant protection. In the high forests of Central Africa, these gorillas live in family groups led by a dominant silverback. Their days are filled with foraging, resting, grooming, and the steady work of keeping a group together. What makes their story remarkable is that numbers have increased compared with past lows, showing that dedicated conservation can change the direction of a species. Yet, the same factors that helped recovery also reveal fragility. Their habitat is limited, and it sits alongside dense human communities. Disease risk is serious because humans and great apes share many vulnerabilities. Rangers and trackers monitor groups, enforce protected boundaries, and reduce poaching pressure. Tourism can support protection by funding jobs and park management, but it must be managed carefully to reduce stress and illness transmission. The mountain gorilla shows how success can be real and still delicate. Recovery is not a finish line. It is a daily practice. The vaquita is harmed by gill nets meant for another fish called totoaba. This is one of the most tragic kinds of threat because it is indirect. Gill nets set for toaba can hang in the water like invisible walls. A vaquita swimming into that mesh cannot simply back out. As a breath-holding mammal, it must reach the surface. When it cannot, the outcome can be fatal. The Toto araba is sought for its swim bee, which has driven illegal fishing despite bans and patrols. That creates a chain of pressure that reaches the vaquita, even though the pulpus is not the target. Conservation here involves net removal, enforcement, and supporting fishing methods that do not trap non-target animals. It is difficult work because it happens in busy waters, where people make their living. The vaquita situation shows how tightly connected an ecosystem can be to economics and trade. One illegal market can ripple outward and endanger a whole species. The beluga sturgeon can live for many decades, and overfishing devastated its numbers. This fish is built like an ancient armored vessel with bony plates along its body and a mouth designed for bottom feeding. It grows slowly and reaches maturity late, which is a strategy that can work in stable rivers and seas where adults survive for many years. The problem is that heavy fishing can remove those long-lived breeders faster than they can be replaced. Demand for caviar has been a major driver, and once older adults are gone, the population loses not only numbers, but also the reproductive engine that produces future generations. Sturgeon also need suitable river conditions for spawning and early life stages, and those conditions can be altered by pollution and river engineering. Conservation efforts include fishing restrictions, enforcement against illegal harvest, hatchery programs, and habitat work. But recovery is slow because the biology is slow. The beluga sturgeon teaches a hard lesson. When a species invests in longevity, it becomes extremely vulnerable to sudden, intense exploitation. The sailor's habitat is fragmented, making it difficult for mates to ever meet. Even when an animal still exists in the wild, isolation can make it feel as if it is fading. The saw lives in forested mountains, where roads, logging, and human activity can break continuous habitat into separated pieces. For a rare animal, that separation can become a cruel barrier. Individuals may occupy valleys that look suitable, yet they may never encounter another scola for years. That can limit breeding, reduce genetic exchange, and increase the chance that a local loss becomes permanent. It also makes conservation harder because protection cannot focus on one spot alone. It must protect corridors, the quiet connective tissue that lets animals move between pockets of forest. Scientists rely on camera traps, environmental DNA, and community knowledge to confirm presence, since direct sightings remain extremely uncommon. The Siola story is not only about numbers, it is about connection. A species can be present, yet functionally alone. The axolotl's wild habitat is shrinking because its lake system has been altered. In the wild, this animal is tied to one place, the remaining canals and wetlands of Zoimilo near Mexico City. What was once a broad lake system has been drained and reshaped over centuries, leaving a network of waterways that now sit beside intense urban life. Water quality can swing quickly, and pollution reduces oxygen and changes the plants and insects that young amphibians depend on. Another pressure comes from introduced fish that eat eggs and larvae and also compete for food. Even when an axolotl survives, it may be boxed into small stretches of habitat with few safe nesting sites. Conservation work includes restoring canals, improving filtration with plant-based systems, and creating refuges that keep invasive fish out. This is not a distant wilderness story. It is a reminder that a globally famous animal can be fighting for survival in the shadow of a city. The Solnauten has poor eyesight, so it relies heavily on smell and touch.
When it moves at night, it does not scan the world with sharp vision. It reads the ground instead. The snout sweeps low, sampling scents like a living detector, and the whiskers and sensitive nose help map spaces the eyes cannot.
You can imagine it as a forager built for leaf litter, where the clues are chemical and tactile rather than visual. It probes under fallen branches, nudges stones, and follows faint trails left by insects and small prey. That sensory style also makes it vulnerable to sudden changes. A new predator does not need to be seen to be deadly, and a new obstacle in the forest can become a hazard if roots are disrupted. Light pollution and human disturbance can also shift the nocturnal rhythm it depends on. Protecting this animal is partly about habitat, and partly about allowing darkness and quiet structure to remain. It survives by feeling its way through the night, and that night must still exist. The Philippine eagle pair bonds for life, and it grazes only one chick at a time. For a bird this powerful, family life is surprisingly slow and careful. A bonded pair invests in a single young with intense focus, because raising an eagle chicken in rainforest is a long project. The nest is often built high in a large tree, and it becomes a central place the adults return to again and again. One parent may guard while the other hunts, bringing food back through the canopy, in a landscape where prey can be scarce if forest is degraded. Because only one chick is raised, each breeding attempt carries enormous weight. If a nest fails, the lost time cannot be replaced quickly. That is why protecting nest trees and surrounding territory matters so much, and why disturbance near an active nest can have consequences beyond one season. This eagle is not only rare, it is living on a schedule that makes every success precious. The Iberian lynx depends on rabbits, so disease in prey can threaten the cat. Imagine being a predator whose main food source can crash almost overnight. The Iberian lynx is highly specialized for hunting rabbits, and that specialization once worked brilliantly across Mediterranean scrubland. When rabbit populations decline from disease outbreaks, the lynx does not simply switch to a new staple without cost. Hunting becomes harder, territories may expand, and raising kittens becomes riskier because a nursing mother needs reliable food close to shelter. Conservation has had to think like an ecosystem planner. Protecting the cat also means restoring rabbit habitat, improving shelter burrows, and managing landscapes that support healthy prey numbers. In some areas, people work to reduce the factors that weaken rabbits, including habitat simplification and human pressure. The lynx's story shows a chain reaction in nature. Saving a predator is not always about the predator. Sometimes it starts with grass, shrubs, and a small animal that carries the whole food web on its back. The Adax has wide hooves that help it walk on soft desert sand. In dunes and loose sand, a narrow hoof sinks, wastes energy, and turns every step into a struggle. The ADAC solves this with wide-split hooves that spread its weight, giving it better support on shifting ground. That small design chain shapes its entire lifestyle. It can travel across sandy basins, where other hoofed animals would tire quickly, and it can reach scattered feeding areas that appear briefly after rare rains. Desert life is full of these short windows, a patch of new growth, a cooler night, a stretch of cloud cover that reduces heat stress. The Adax is built to seize those moments, then endure long stretches of scarcity. The tragedy is that the desert no longer guarantees safety from human reach, and wide hooves cannot outrun vehicles. Its feet are an adaptation to sand, not to modern pursuit. Still, they are a beautiful example of how survival can be engineered into the simplest part of the body, one step at a time. The proboscis monkey is an excellent swimmer, and it often crosses rivers to forage. Rivers in Borneo are not just barriers, they are highways, feeding grounds, and escape routes. These monkeys live close to water, and they regularly leap in to cross channels between forest patches. Swimming lets them reach fruiting trees and young leaves that change with the seasons, especially along river edges where plant growth can be lush. It also offers a way out when danger appears on land, since a quick prop into the river can break a predator's chase. Crossing is not casual because crocodiles exist in some waterways and strong currents can make a mistake costly. That makes each crossing a decision shaped by group movement and timing. Their river life also links them to human activity, since boats, logging, and settlement often concentrate along the same banks. Protecting them means protecting riparian forests, the strip of habitat that keeps shade, food, and safe access to water. For proboscis monkeys, the river is not the edge of the world. It is part of the map. The shoebilt's bill shape helps it see slippery lungfish with precision. That massive bill looks heavy, yet it is a finely tuned tool. The broad edges act like a clamp, and the sharp tip can hook and hold prey that would otherwise slide free. Lungfish are especially tricky because they are muscular and slick, and they can twist violently when grabbed. The shoebilt's approach is to strike down with force, then use the bill's shape to control the prey's body rather than just pinning it. It may reposition what it has caught, adjusting grip until the prey is aligned for swallowing. This is not delicate work. It is controlled power performed in slow water where reeds and floating plants can hide movement. The bird's success depends on healthy wetlands with stable water levels, because lungfish and other prey rely on those conditions too. The bill is the headline feature, but it points to something deeper. This bird is a specialist, built for one of the swamp's most stubborn meals. The tuatara can live for more than a century with very slow growth. This reptile moves through life at a measured pace, growing slowly and reaching maturity only after many years. That slow schedule can be an advantage on cool islands, where food can be seasonal and metabolism can stay low. It also means that every adult carries decades of survival experience, and losing an adult is not like losing a young animal that will be replaced quickly. The tuatara's long life is tied to stable conditions, safe burrows, and the absence of introduced predators that can wipe out juveniles before they ever reach breeding age. Climate also matters, because incubation conditions can influence development, and shifting temperatures can disrupt the balance a population has relied on for generations. Conservation has focused on protected habitats and careful translocations to safe islands and fenced areas with monitoring that plays out over decades rather than months. The tuatara's longevity is not a fun statistic. It is a reminder that some species live on a timescale that demands long attention from us too. The coelacanth gives birth to live young after an exceptionally long pregnancy. In deep water, life runs on a slow clock. The coelacanth is part of that slow world,
and its reproduction reflects it. Rather than releasing eggs into the open sea, it keeps developing young inside its body for a very long time, then gives birth to fully formed juveniles that can swim immediately. This approach lowers the risk of delicate eggs drifting into danger, but it also means the parent invests heavily in each reproductive cycle. When reproduction is slow, losses are harder to replace, and accidental capture can have an outsized effect. Deep water species also present a research challenge because their breeding behavior is difficult to observe directly and every detail is hard to obtain. The coelacanth's live birth is one of those facts that changes how you imagine it. It is not just a survivor from ancient lineages. It is also a careful parent in a dark environment, spending many months building the next generation before releasing it into the depths. Many rare animals disappear before they are ever discovered because habitat loss moves faster than science. A species does not have to be famous to be real. Many are small, nocturnal, seasonal, or limited to a single valley, reef, or mountaintop. Some live as larvae in water for only a brief part of each year. Others are insects that emerge for a few days, then retreat back into the soil. When forests are cleared, wetlands are drained, or reefs are damaged, those narrow lives can end without a name ever being written down. Scientists do discover new species every year, but the work is slow. It requires surveys, careful comparisons, and often genetic analysis to confirm what is truly distinct. Meanwhile, land use can change faster than any research program can track. This creates a quiet kind of tragedy. Extinctions that do not make headlines because the animal was never widely recognized. It also creates urgency. Protecting habitats protects known species, and it also protects unknown ones waiting in the shadows. In many places, conservation is not only saving what we love, it is saving what we have not met yet. As we come to the end of our journey through rare animals, you might notice how wide the world feels now. We wandered from hidden wetlands to mountain forests, from desert sands to cold rivers, and into oceans that still keep their secrets. We met creatures shaped by isolation and time, animals that survive in small pockets of earth where conditions have to be just right. Some endure by blending into leaves and kelp. Some rely on strange senses, tasting the water with nerves or reading the dark with touch. Some live on schedules that move slowly, measured in long lifespans and rare breeding seasons. And some are so scarce that their whole future can rest on one protected place, one safe corridor, one season that goes well. If any of these stories stayed with you, I'd love for you to support the channel in whatever way feels easy. You can leave a kind comment, share the video with someone who might enjoy it, or subscribe so you can find your way back next time. It helps this little corner of the internet stay alive and growing. Now, you do not need to hold on to every detail. Let the names and places drift away. Let your shoulders soften and allow your jaw to unclench. Feel the weight of your body settling more fully into rest. If you are still awake and you want one more calm adventure, there will be another video waiting on the screen, ready whenever you are. For now, let the world soften at the edges and let your breathing find its own slow rhythm. Sleep well and good night.